Hey everyone, welcome back. In this video, we are going to cover another velocity time graph. Please take a second to pause this video and read through all of the given information and take a look at the graph over on the right, and then meet me back here for the problem solve. Okay, so jumping into part A, it asks us to find the velocity of runner A and the velocity of runner B at time t equals 2 seconds, and then indicate the unit of measure. Okay, so let's start out with the velocity of runner B, which is given by this function here. So to do that, all we are going to do is we are going to do v of 2 equals 24 times 2 over 2 times oops, excuse me, let me fix that. 2 times 2 plus 3. So then we are going to get 48 over 7. Now for the units, this would be in meters per second. And that's given here as well. It says the velocity in meters per second of runner B. You could also plug that into your calculator, and then as a decimal, you would get 6.857 meters per second. Okay, good. So that was pretty straightforward for runner B. Now let's do runner A, which will require us to use this graph over here. So at 2, if we were to follow our function up, we would be somewhere, looks like probably somewhere approximately around 6. But of course, we can't just use this value, right? We have to get the exact value. So what we're going to have to do is we're going to have to find the equation of this straight line here, and we're going to have to use that to get the exact output value when our time is 2. So in order to do that, we're going to think back to our simple Algebra 1 equations, and we are going to do point-slope form. So to get the slope of this line, we can also just do rise over run, which is really straightforward in this case since we're going through the origin of 0, 0. So we're going up 10 and over 3 to get to this point here. So our slope is going to be 10 over 3. And then I said we were going to use point slope form, which we still could, but also it's really easy just to do slope intercept form here since our y-intercept is 0, right? So really the equation of this line is just going to be y equals 10 over 3x plus 0, or just y equals 10 over 3x. So now let's go ahead and input 2 for our x value and get our y value, which is going to represent our velocity, of course. So we're going to do y equals 10 over 3 times 2, which gives us 20 over 3. So this would be the velocity of runner A in meters per second. And then, of course, we could also get the decimal value, which plugging it into my calculator on the side, I got 6.67 meters per second for runner A. Okay, great. Moving on to part B. Okay, so part B asks us to find the acceleration of runner A and the acceleration of runner B at time t equals 2 seconds and indicate unit of measure. So the acceleration is the derivative of the velocity. I'll repeat that one more time. Acceleration is the derivative of the velocity. So first, let's go ahead and do runner B again. Let's take the derivative of this function. I've put the quotient rule here up in the upper right. This is from my Unit 2 formula sheet available on Patreon if you'd like to check that out. And then let's go ahead and take the derivative. So you can see here, we're going to take the derivative of the numerator, which is 24, and we are going to multiply it by our denominator, which is 2t plus 3. Then we're going to do minus our numerator, which is 24t, times the derivative of our denominator, which is just 2. And then all of this is going to be over our denominator squared. So 2t plus 3 squared. So let's just clean this up a bit. I'm going to go ahead and distribute this in, and I'm going to get 48t plus 72 minus 24t times 2 is 48t over, again, my same denominator. Now I'm just going to cancel those out. They equal 0. And so then this is now my v prime of t function. So v prime of t for runner B is 72 over 2t plus 3 squared. Now I'm going to evaluate this for time equals 2. So my acceleration at time equals 2, which of course is the same as v prime of t at 2, is equal to 72 over 2 times 2 is 4. So I'm going to go ahead and just write that as a 4. And then from here, I'm just simplifying this down. So 4 plus 3 is 7. 7 squared is 49. So this would give us 72 over 49. Now let's talk about the units. Well, we basically have meters per second, right? Our velocity is in meters per second, and then our time is in seconds. So this is going to be in meters per second squared. Again, we can also get this into decimal form. Doing this on the side quickly on my calculator, I got 1.469 meters per second squared. Okay, great. And this is for runner B. I'll just put that right there. Okay, now let's do a similar thing for runner A. So again, for runner A, we're going to be using this graph here. So again, the acceleration is the derivative of the velocity. What does that mean? What is the derivative? The derivative is the slope, right? So all we have to do to solve this is we have to get the slope of the function at time equals 2. Well, what is the slope here? Turns out we actually already found this slope for part A, and the slope, again, is just rise over run, right? So it's just 10 over 3. So for runner A, the acceleration at t equals 2 is just our slope, which is 10 over 3. And again, plugging that into my calculator quickly on the side or doing it in my head, I got 3.333 meters per second squared. Same units as, of course, for runner B. All right, let me just circle that. Okay, great. Thanks so much for watching, and I'll see you in the next video.